Hello guys, welcome to the lecture 22 of machine learning series. In this video, we'll be discussing about one-hot encoding technique in very detail. Now, before discussing about this one-hot encoding technique, first let us try to understand why this technique came into existence. Okay, in our previous video, we have already discussed about a technique which converts ordinal categorical data into numerical data, that is ordinal encoding. Okay, now there is a technique which converts nominal categorical data, that is when there is no relationship among the categories, we say that particular data as nominal categorical data. Okay, now to convert this nominal categorical data into numerical data, there is an technique. Okay, that technique is called one-hot encoding. Okay, now let us see how this one-hot encoding actually works. Okay, now I'll be taking an example to explain this one-hot encoding. Okay, so this is that particular data. Okay, now this particular data contains two columns. One is ID and second is color. Now among both these columns, this color is my categorical column which contains three main categories. Okay, first is red, second is blue, and third is green. Okay, it basically contains three main categories. Now I need to encode this categorical data. Okay, so you can see that there is no relationship among any of these categories, so it's a nominal categorical data. Now I need to somehow encode this particular data. Okay, now I am using one-hot encoding to encode this particular data. Now let's see how one-hot encoding works. Okay, so you can see that I have created a separate table. Okay, I have created a separate table representing the same data. Okay, what I am doing over here is to convert these categories, okay, these categories into nominal data, sorry, these categories into numerical data. What I am doing is I am just creating dummy variables, that is dummy columns. Okay, so this red category is represented as color red. Okay, so I'm just creating some dummy variables. Okay, you can see that here is my red category, and corresponding to this I have created a dummy column. Okay, dummy column or dummy variable. Now corresponding to my category blue, I have also created another dummy column, that is color blue. Okay, you can see same for the green as well. Okay, so now I have transformed this particular data. Okay, this particular data I have transformed to this type. Now I need to somehow fill all the values over here. Okay, so I have my tabular structure ready with all the three categories in it. Okay, so now my first ID. Okay, now if you see my first row, I have ID 1 which corresponds to color red. Okay, so in my transform table also I'll be having same ID column. Okay, you can see that my first ID. Now this first row must represent somehow red color. Okay, now what I am doing to this is I'm just putting 1 over here. Okay, so in that particular column which represents red, I'm just putting 1 over there, and the remaining two columns are zeros. Okay, so next I have my second row, that is 2. Okay, with ID 2. Now for ID 2 I need to represent blue color. Okay, now for blue color, where is my blue? It is my second column, right? Okay, so that is why I am putting 1 over here, and rest of the 2 are zeros. Okay, now my third row represents green color. No, I need to somehow represent green color, right? So that is why I am putting 1 over here, and rest of the 2 are zeros. Okay, so in this way you convert, okay, you convert categorical data into numerical data. Okay, now how this conversion is done is, now this color red is represented as a vector. Okay, in ordinal encoding we have converted categorical data into direct numerical data. Okay, but we are converting this nominal categorical data into vector form. Okay, in case of one-hot encoding we are converting nominal categorical data into an vector form. Okay, there we have directly converted into some numerical form, that is it may be of any integer or it may be of any float value, but in case of one-hot encoding we are converting it to an vector. Okay, we generally represent an category with the help of an vector. Now the red color is represented as 1, 0, 0. Okay, now the blue color is represented as 0, 1, 0, and green color is represented as 0, 0, 1. Okay, so in this way you convert some categorical data into numerical data. Okay, so you don't just directly convert to some integer or float value, you just convert it into an vector form. Okay, so in the entire data, this vector represents red color. Okay, where you find this vector, it represents red color. Okay, so where you find this particular vector, it represents blue color. Okay, so now you may have a doubt that now if I have 100 different categories, should I represent 100 different dummy variables? The answer is yes. Okay, if you have 100 different categories, you need to create 100 different dummy variables over here. Okay, dummy columns over here, and you will be getting the vector size as 100. Okay, for each category you will be getting the vector size as 100. Okay, so there is no option for that, you definitely need to create. Okay, so this is how one-hot encoding actually works. One-hot encoding is a technique which converts nominal categorical data into numerical data. Okay, but remember, this conversion is not smooth. Okay, we'll be facing an important problem due to this conversion, that is dummy variable trap. Now I'll be explaining this dummy variable trap in very detail. Okay, I'm using the same example as previous. Now you can see that I have converted this particular data into this kind of data. Okay, you can see both the tables comparison. This data is converted into this data, right? Now here these columns are called dummy variables. Okay, remember, these columns are called dummy variables. Now if you keenly observe these three columns, you can see that there is a mathematical relationship. Okay, just exclude this id column. Okay, just exclude this id column and only observe these three columns. Okay, if you observe keenly, there is a mathematical relationship existing between these three columns. Okay, now what is that mathematical relationship is? You can see that the elements, okay, if I add all the elements of that particular row, it results to 1. Okay, same with the second row as well. Okay, 0 plus 1 plus 1, you can see that it is 1, and it is also equal to 1, and it is also equal to 1. Okay, when I add all the elements of a particular row, that is resulting to 1. Okay, so which means there is a mathematical relationship among the columns, that is the columns are becoming dependent on each other. Okay, always remember, in machine learning or in deep learning, whenever and data is given to you, you must make sure that all the features, okay, remember, all the features must be independent of each other. Okay, all the features must be independent of each other, and there must be only one dependent feature, that is target column. Okay, there must be only one dependent column, that is target column, but the rest of the features must be independent of each other. Okay, if they are dependent on each other, then training and machine learning algorithm or deep learning model is difficult. Okay, it gets trained in a wrong manner. I'll be explaining the reason while I'll be discussing about the machine learning algorithms. Okay, so due to this one-hot encoding, what's happening is there is existing and mathematical relationship. Okay, so this is called multicollinearity. Okay, when the columns depend on each other, then that is called multicollinearity. Okay, multicollinearity. Okay, always remember, we don't want multicollinearity in our data. Okay, always remember, we don't want multicollinearity in our data, and we somehow try to remove this multicollinearity. Okay, so this problem, okay, this problem is called dummy variable trap. Okay, this problem is called dummy variable trap. Okay, that is DVT. Okay, it's the most famous problem, that is dummy variable trap. So you need to somehow figure out a solution to this dummy variable trap problem. Okay, so always remember, this dummy variable trap problem occurs due to multicollinearity in data due to one-hot encoding. Okay, so you need to somehow remove this dummy variable trap, and there is a simple solution to this dummy variable trap, that is removing an column. Okay, removing an column from the newly created data set. Okay, you can see that if I remove this column, what's happening now, the sum of these rows, okay, the sum of elements of these rows is equal to 0, and rest of the elements is rest of the rows is 1. Okay, but there is no relationship among the columns. Okay, you can see that there is no relationship among the columns being existed. Okay, so you have removed the multicollinearity just by deleting an column in the newly formed data. Okay, so always remember, whenever you find some nominal categorical data, just directly don't one-hot encode. Okay, after performing one-hot encoding, you need to remove this particular column. Okay, always remove the first column. Now if you have 3 categories, okay, if you have 3 categories, you don't need to have 3 columns, okay, 3 new dummy variables in your newly created data. Okay, you must have n-1, okay, n-1 columns. Okay, if you have n categories, you must have n-1 dummy variables. That's it. But you need not have n variables. Okay, so this is the dummy variable problem and its solution. Okay, so here this color red is represented by 0, 0, and color blue is represented by 1, 1, and color green is represented by 0, 1. Okay, you can see that very simple solution, right? Okay, even after removing this particular column, there is no impact on the data. Okay, there is no impact on the representation. Okay, so this is basically dummy variable trap problem, and this is a solution to that particular problem. Okay, always remember, due to one-hot encoding, okay, due to one-hot encoding, we'll be having multicollinearity in our data. Now this multicollinearity in the data brings us dummy variable trap problem. Now to remove this dummy variable trap problem, we just consider n-1 columns. Okay, not n but n-1 columns. Okay, so this is dummy variable trap problem. Now you may have a doubt that due to one-hot encoding, the dimensionality of the data is increased. Now when this increased dimensionality data is fed to a machine learning algorithm, the training time of the machine learning algorithm is increased. Okay, the doubt is absolutely right. Now to prevent this problem, what we do is we follow some kind of tricks. Now among this, the most common trick that people follow is converting various categories into a single category that is called others. Okay, I'll be explaining you how. Now let's say we have data of car company. Okay, car company. Now in this car company, we have various kinds of cars. Okay, let's say it may be Benz, or it may be Audi, or it may be some, okay, various other car brands. Okay, we'll be having some hundreds and thousands of car brands, and encoding these car brands is really a difficult task. Now what we do is we pick few car brands. Okay, we pick few car brands which are like less in number. Okay, now most of the people don't buy Benz, right? Okay, these premium cars are not bought by most of the people. Okay, now when it comes to Maruti Suzuki, or it may be Toyota, okay, most of the people purchase this kind of cars. Okay, these kinds of budget cars, right? Okay, when it comes to premium cars, only limited people purchase them, so the number of cars sold will also be in less in number. Okay, so what we do is we pick these kind of categories. Okay, we just segregate data into these two categories. One is premium cars and other is some budget cars. Okay, it may be budget or it may be cost efficient cars. Okay, so we, in this way, we segregate into two categories. Okay, now what we do with this first category, that is premium cars, is we set this premium cars to others. Okay, as the number is very less. Okay, as the number of cars sold or number of cars purchased by the people is very much less, what we do is we kind of convert all these categories into a single category called others. Okay, into single category called others. Okay, all these premium car brands are segregated to a single column, that is others. Okay, so now under this others, like around 30 to 40 car brands fall under it. So what I am doing, I am just reducing 30 to 40 vectors, right? Okay, 30 to 40 numbers in my vector space. Okay, that means my vector size is definitely being decreased. Okay, now due to this one single change, the vector size is definitely being decreased, right? Okay, so this is how we try to decrease the dimensionality of our data. Okay, just by following few of the tricks, we try to reduce the dimensionality of the data. Okay, so in the next part, we'll be definitely implementing on how this one-hot encoding is performed in very detail. First, I'm just importing my necessary libraries. First, I'm importing pandas as to work on the tabular data, and second, I'm importing torch library to work on PyTorch, its required library, and then I'm importing this functional, because this functional provides us one-hot encoding function. Okay, so that is why I'm importing it as F, and then I'm using the Seaborn library so as to obtain like pre-processed datasets. Okay, the Seaborn has many pre-processed dataset, so among them I need Titanic dataset, so that is why I'm importing this Seaborn library. Okay, you can see that I've just loaded my Titanic dataset, and what I have done is I have removed all the empty values. Okay, you can see that in many datasets we find NaN values or some empty spaces in the datasets. Okay, so what I have done is I have just removed those empty spaces when it comes to 6 and embarked column. Okay, if any empty spaces are present, empty spaces or NaN values are present in 6 or embarked column, I'm just dropping those rows. Okay, I'm just dropping those rows and I'm just resetting the index. Okay, now what this reset index does is, now let's say this is my 6 column and this is my embarked column. Okay, now I have now let's say this is my ID column, so I have 1, 2, 3 as my IDs. Okay, so in my first row the 6 column is empty and embarked column is, let's say, some random variable, that is C. Okay, now here 6 is male and yes and female and let's say another C. Okay, now if you see I have just dropped my empty rows, right? Okay, so this particular row gets dropped. Okay, now after dropping this particular row, if I don't reset my index, then my index becomes 2 and 3. Okay, even after removing this particular row, my index becomes 2 and 3. But when I reset my index, what happens is I'll be just resetting this particular row as 1 and this particular row as 2. Okay, so this particular after eliminating this particular row, my entire index get reset. Okay, so that is why I have just reset my index and drop is equal to that means I'm just dropping, and then I'm just creating two tensors, that is sex tensor and embarked tensor. Okay, now I'll be explaining what I'm doing over here. Okay, torch.tensor. Okay, when I use this torch.tensor, when you want to convert some numpy arrays to tensors, so in that case I use this torch.tensor. Okay, now what I'm doing, I'm just extracting this sex column. Okay, that is all the values in the sex column. Now they are in string type. Okay, now they are in string type. Now what I'm doing, from string type to I'm converting it to category. Okay, now from category what I'm doing, I'm just converting it to numericals. Okay, I'm just converting it to numericals by cat codes. Okay, by cat codes I'm just converting this categorical data into numerical data. Okay, now what happens over here, now let's say in my 6 column I have male and female. Okay, they get represented in this way. Okay, male and female. Now this text is converted into categories. Okay, first they are converted into categories. Now using this cat codes, what happens is, now this M gets converted to 0 and F gets converted to 1. Okay, or either the way happens. Okay, M may be converted to male, M may be converted to 1, or F may be converted to 0 as well. Okay, so either any of the way can happen. Okay, same with the embarked tensor as well. Okay, same with the embarked tensor, first it gets converted into category and then to cat codes. Okay, so if we use this dot cat dot codes, what happens is they gets converted to some numerics. Okay, they basically convert to some numerical values. Okay, now after that I'm just using this dot values to convert it to numpy. So after this conversion to numpy, what I'm doing, I'm just converting it to tensor. Okay, so how is the flow? First I'm just extracting that particular column and I'm converting from text to category, and from category to some numerical value, and from that numerical value to some numpy, and from numpy to this tensor. Okay, so this is how my entire flow is happening in this particular cell. Okay, now next what I am doing is I'm just picking up this sex tensor and I'm converting it to long type. Okay, that is int 64. Okay, I'm converting this sex tensor to long type. Okay, now this conversion is important because this one-hot encoding basically works on long data type. Okay, so that is why I'm just converting it to long, and then after that I'm converting it to float, because machine learning algorithms expect some float values. So that is why I'm just converting it to float type. Okay, so after one-hot encoding, so first I'm converting it to long type. After conversion of long type, I'm just one-hot encoding this sex column, and this is stored in sex one-hot, and then I'm converting it to float type. Okay, so same with the embarked as well. Okay, same with the embarked tensor as well. Okay, so from tensor to I'm converting it to long, and after conversion from long, I'm just doing one-hot encoding and then converting it to float type. Okay, so next what I'm doing, okay, I'm just dropping my first column. Okay, I have said you that we face dummy variable trap, right? So to avoid the dummy variable trap, what I'm doing is after that one-hot encoding, I'm just dropping my first column. Okay, I'm just dropping my first column when it comes to 6 and when it comes to embark. Okay, you can see that I'm just dropping my column. Okay, I'm just starting my 6 one-hot with first column. Okay, not with the 0th index. Okay, I'm starting with the first index. That means I'm dropping my 0th index data. Okay, so next what I'm doing, I'm just converting it to like data frame. Okay, that is 6 underscore df is equal to p dot data frame, and I'm providing this particular data. Okay, that is 6 underscore one hot, and I'm providing the column as this, that is I'm providing my own column. Okay, that is 6 mail. I'm just providing my own column name, and embarked underscore df is equal to p dot data frame. I'm similarly I'm just converting it to data frames. Okay, they are in the form of some arrays, and I'm just converting it to in the form of data frames. Okay, so then what I'm doing, I'm just concatenating with the original data frame. Okay, you can see that this is my original data frame. I'm just performing concatenation operation with original data frame and both these columns. Okay, 6 underscore df and embarked underscore df. Okay, along the axis one, means along the row way. Okay, along the rows I'm just concatenating. Okay, so after that I'll be getting my final df, and I'm dropping 6 and embarked columns from the final df, because I already have this one hot encoded 6 and embarked df. So sorry, 6 and embarked column. So that is why I'm dropping my original 6 and embarked column, and this is my final data. Okay, you can see that what is my, yeah, this is my one hot encoded 6. You can see that 1 represents male or 1 represents female, or 0 represents male or female. Okay, so this is how one hot encoding happens, and you can see that embarked q, that is Queenstown, and embarked Southampton. Okay, so this is how we represent our embarked column. Okay, so this is entire one hot encoding. Now this one hot encoding in PyTorch, it is some difficult way, but when it comes to scikit-learn or using pandas, they provide much easier way. Okay, basically in PyTorch you need to hard code everything, but this scikit-learn, or if you use pandas, they provide you some direct functions and various other parameters in the functions to directly one hot encode. Okay, so it is simpler when you use scikit-learn or pandas. Okay, so this is the implementation in PyTorch. Okay, the code is slightly difficult, but we don't have any other option other than this. So this is the entire video of one hot encoding. I'll be providing the entire notebook in the description. If you want to try, you can give it a try on some different real world dataset. Okay, so hope you guys like this video. If you like the video, please like, share and subscribe. Thank you.